In order to try and figure out what's going to affect the rate of reaction, we're going to use collision theory, which you would have met GCSE. In order to a reaction to take place, obviously the particles have to collide. They have to meet each other. So in the example that we were doing earlier, we have calcium carbonate reacting with sulfuric acid. If I keep in one container my calcium carbonate, and in a different container I keep my sulfuric acid, not a lot's going to happen, is it? If I got them over here, not a lot's going to happen, they can't meet. In order for them to meet, the first thing I have to do is mix them together, and then the particles actually have to collide. So, if they're kept separately, it's kind of common sense, nothing's going to happen. But if we can mix them up, and the particles collide, they meet, then I'm going to get a reaction take place. What we're going to look at is how we can change how fast my reaction goes, and we use collision theory for that to work. So the first thing we're going to look at is concentration. How does concentration of solutions affect the rate of reaction? So this would be number one, concentration of solutions. Well, if in our example that we looked at with calcium carbonate and sulfuric acid, if I've got my little beaker, and in my beaker I have my calcium carbonate, and I have a concentration of sulfuric acid being 1 mole per decimeter cubed, and I have another beaker which I also have calcium carbonate in there, and I have sulfuric acid, which I'm going to add is now going to be 2 mole per decimeter cubed. Which one's going to be the fastest? That one or that one? This one will be fastest. Okay, that's kind of like common sense. This is more concentrated, it's going to be faster. Why will it be faster? Well, I'm going to have double the number of sulfuric acid particles in there, so they're far more likely to collide. So, what you may want to think about is use the party theory in terms of explaining collision theory. Let's say in the room we decide to have a party, okay? So, you're here, we'll probably have to be blindfolded for this to work. So, we've got you here, okay, and into the room, maybe through the fire exit, I introduce one boy, okay, who will be in red, okay. The aim of the game is for you to meet the boy. In order for you to meet the boy, the first thing you have to do is you have to collide with him, yep, first of all. You are all walking around in random directions, because that's what particles are doing, as is he. Okay. What is the likelihood of you colliding?
1 in 5 chance?
Yeah, not very yet. It's going to take a while for one of you to finally meet him, isn't it? Poor guy. Okay. However, if I put far more into the room and they all randomly walking around, I am far more likely, or you are more likely, to have a successful collision, because I've got more boys in the same volume as you. So there's more likely to be, so it's going to be a much faster reaction, it's going to be more successful in terms of that. So by increasing the concentration, I increase the rate of collision, and it's more likely to happen. So concentration of solutions, we can say, if there are more particles in the same volume, there will be more collisions per second. It's really really important that you always relate it to the collisions per second. So if there are more particles of the same volume, there will be more collisions per second. Therefore, the rate of reaction will increase. We can say the same thing for pressure as well. Pressure is very similar to concentration, but pressure is going to work for what state?
Okay.
Gas state, yeah. So if we now think of this as being a gas, how would the effective collision vary if I took you in this room and I started to move this wall and squash you all together? It will, yeah. If you're in a smaller volume, you can't row so far, you're going to collide more often. So by increasing the pressure has the same effect. So increasing the pressure
It was the second.
for gases. Yeah, shall we say? Number 2. Increasing the pressure for gases has the same effect as increasing the concentration. So use the same argument. There are more successful, more collisions per second.